Thank you, and good morning. It's great to be here at Pixel Pioneers. I feel like I should do the Apple pose. Did anyone watch the keynote from Apple recently? I'd love it if we get my slides up here. I do have some slides. There we go. Fantastic. Listen, it's not lost on me that this is the first talk of the day, and I have so much power. I get to set the tone, really, for the entire day. And so, if it's not too much trouble, I'd like to just go over a few asks of you as attendees for the rest of the speakers and myself as well. We do a lot to prepare a great presentation for you. So if you want to engage, if you want to literally clap or shout out things or whatever, that's welcome. There's also many different kinds of people, right? Some of us actually listen better when we're on our phone. This is not a sign of disrespect, at least not to me. But if you are on your phone, I'd encourage taking notes and maybe sharing that publicly, because learning in public benefits everybody. If you are able to not use your phone, then of course the attention is valued. Anyway, I'm not here to tell you how to live your life. I feel this sense of responsibility as the first talk. But let's talk a little bit about me. I'm Tejas. That's pronounced like contagious. I'm not contagious, last I checked anyway. Maybe my joy is contagious, I don't know. But some marketing person can really spin that, you know? And I've had the privilege of working at a number of tech companies in various capacities over many, many years. I have worked in tech for a very, very long time. Some would say too long. I look forward to the day I just garden all day or something. In any case, today I'm a developer relations engineer for generative AI at a company called DataStax. DataStax is a company that creates developer tooling for AI engineers and AI workflows. And look, this talk is titled "You Are an AI Engineer," but I think off the bat, it's extremely important to to emphasize that this isn't some hype-driven Web3 is going to change the world type of hype-chasing talk, okay? And it's unfortunate that the AI space is sort of conflated with this. Like company valuations, you just put the word AI in a startup and they'll raise $200 million, you know? This is not that. In fact, this is the opposite. Together in our time, what we're gonna do is identify the nuance around this and give everybody who maybe hasn't yet had the time because of the demands of everyday life, give you a working understanding of AI engineering, its distinction from machine learning engineering, and how you could be an AI engineer. And if that's a path you want to go down, I hope to give you those tools to make it accessible to you. Okay, that's the whole intention here. I don't really care for hype. I care for detail, nuance, and proper understanding. So with that, let's talk about the term AI engineer. What is this? Look, in preparing for this, and it's also part of my job, I asked a ton of people, some of you even here, do you think one day you could identify as an AI engineer? Do you think you could play in the space? Do you think you could maybe have a job here? Do you think you could build a career around this? And the overwhelming response is no. And this is what I want to fix today, because it's somewhat gatekept. Because the reason I ask is to see what people think, and then I say, okay, why not, right? And the answers, by and large, are, oh, because I don't have a background in linear algebra. I'm not good at machine learning. I don't have a data science career. I feel like there's a lot of academia here. I don't have a degree in mathematics. It's all of this I don't. And I'm here to tell you that the AI engineering, machine learning engineering are different beasts entirely. And that's where we'll spend the bulk of our time today, with some user experience focus, because this is vastly attended by user experience engineers. So hopefully there's a lot relevant to you here. So, okay, if AI engineering isn't machine learning engineering, isn't data science, isn't linear algebra, what is it? There's an excellent article, I'd call it a hallmark article, called Rise of the AI Engineer by a dear friend of mine, Sean Wang. Some of you may know him as Swix on the internet. He is the founder of a company called Small AI, S-M-O-L-A-I. And before AI, he was just doing UI engineering, like me, like all of us. And he has a background in finance. He actually called the AI wave that sort of ChatGPT started, because he was monitoring valuations of companies and noticed, whoa, nobody cares about React. All the companies they're investing in this AI thing. What's going on? And then, surely enough, it happened. And now he founded a company about AI. Anyway, he runs a podcast, has a newsletter. It's called Latent Space. It's sort of the leading resource for people who build with AI. Okay, and on this blog, he's got this article, The Rise of the AI Engineer. And in it, he defines what AI engineering is. And this definition is from him, an expert, but also corroborated by other experts. So if we consider what might an AI engineer be, it's really summarized well with this diagram, right? There's machine learning research and machine learning engineering. There's a strong line down the middle that is the API layer. And behind or in front of, depending on how you see it, behind that, you've got AI engineering. So really, there's black box APIs that behind them have machine learning stuff, and in front of them have AI products. What does this mean? Well, we don't build the models, we don't train the models, we don't fine-tune the models, we use the models. If we think of this from another angle, if we talk just semantics about engineering, what is engineering? It is applying technology to solve problems. Engineering is literally characterized by problem solving. So if we apply engineering to solve problems, if we apply technology to solve problems, we do engineering. If we apply AI technology to solve problems, we do AI engineering, right? In a very crude way, I think it really, like top contour, we could say, if you speak JavaScript, you do a network request to some OpenAI model that is data science, that has its roots in data science. You do a network request, get some generated output, and use that to solve a problem, you've done effectively AI engineering. Okay, and this is, again, this is not my definition, this is from Sean Wang, and it's also further approved of by Andrej Karpathy. At the bottom, there's this beautiful quote. It says, in numbers, there's probably going to be significantly more, and that's my hope here, is that I help there be significantly more AI engineers than there are ML, machine learning, or large language model engineers. One can be quite successful in this role without, and these last three words are so important, without ever training anything. And this really cements that distinction. Who is Andrej Karpathy? Former VP of self-driving at Tesla. Literally invented the self-driving mechanisms that drive Tesla, and the co-founder and director of AI and engineering at OpenAI, literally co-founded OpenAI, the company behind ChatGPT. So when he says this, it means something, unlike me, okay? So this is the working definition for AI engineering. One further thing is Sean says on his blog in the same article that this will be likely the highest demand engineering job of the decade. And so I hope this makes a strong case for why I'm doing this talk and why this is important to you, because a lot of jobs, as you've seen, are starting to change and are changing. And I think there's the whole doomer mindset where, oh my God, this is so bad. There's also the optimist mindset where, oh, everything's going to get better and we're going to be artists all day and AI is going to do all the work. I think the truth is somewhere in the middle, right? Some jobs will go, some jobs will stay. The best we can do is just be ready and be prepared for the world to change, because it already is. So that is AI engineering, significantly different from machine learning engineering, and a young space. It genuinely feels like the internet was just invented in the world of AI. A lot of stuff is still being figured out, and it's a space that is open for all and accessible to all of you. Okay, let's talk about AI. I don't know if you've seen Google I/O or the shorter videos of Google I/O in like 60 seconds, where the CEO of Google, Sundar Pichai, just says AI, 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 AI. So it's like they say it 121 times in their keynote. This talk is not that. This talk like expands on what this actually means. So what is AI? Unfortunately, this term has been abused, I would say, for the purposes of like fundraising and making one's company or self look brilliant, when in fact it may not be. AI means many things to many people, and this is a problem. And here, what we're trying to do here is draw some attention to the details, the nuance that helps form the basis of healthier discussions, okay? So there's different kinds of AI, and not all, whoa, is that AI? Not all AI is created equal. So let's talk about some types of AI here. Y'all know Pac-Man, right? The game with the ghosts and this is definitely not AI. So Pac-Man, the game with the ghosts. When you're just going about your maze in Pac-Man avoiding ghosts, and then you eat cherries, and then the ghosts turn blue and avoid you, that's AI. It's just maybe not the AI that's hyped today in the zeitgeist, but that is an example, a great example of rule-based AI, where engineers, programmers like write these rules, like big if-else statements. If cherries, ghost avoid, right? So the rules are known ahead of time and coded in by engineers. And that has existed for a long time, similar to like Mortal Kombat. Like when you play against a CPU, typically that is all just rule-based AI. There's predictive AI that has its roots back in papers published in 1906 by one Andrei Markov, a statistician who literally created what are called Markov chains, predictive models that later have applications in computer science that help you predict the next likely output for given inputs. We all use Markov chains and predictive AI every single day on our phones, because there's this little row above your keyboard that gives you the next word. That's just a big Markov chain. It uses the last word you typed to get the next word. And so some of you may have played this game where you like tap on a suggestion infinitely and it generates like garbage text. That's the problem with Markov chains. It's literally called the Markov property, where it has no memory outside of the latest item, the latest word. And so if it had more context, then you'd have ChatGPT. And that effectively is what large language models are. Finally, there's generative AI, and this is the one that gets the high valuations and the inflated salaries, and this is the one that may currently be a bubble. Okay, I want to draw your attention to that. That might actually be the case. However, Apple just gave it some legitimacy. We can talk about this. So generative AI is powered by deep learning and neural networks that rearrange inputs, or transform them, I should say, into novel outputs. And this is really cool because they are able to do, given the fact that they run on GPUs and so forth, they are able to do an enormously number of high calculations parallelly, right? And so a lot of people have seen demos of AIs generating like websites, and they think, okay, cool, I write a prompt and I get one website. What you don't see is you write a prompt and you actually get like 50 million websites, all in the same time domain. Like a human being can never do this. And this is why generative AI is so popular. So 3 types of AI: rule-based, predictive, and generative. Some companies use rule-based, they use the word AI to talk about rule-based AI that isn't really novel. However, the resurgence of the term, so to speak, is leading to positive outcomes across the globe. There's a university in Vienna, for example, doing really great research on protein folding, assisted by Gen AI. And they are, at least that's what the researchers tell me, they're very, very close to seeing combinations of things that just didn't exist previously that may help them cure like long-standing diseases. Very, very cool. Okay, so let's shift our focus to generative AI specifically, because rule-based has existed for literally decades, and predictive has existed for centuries, so whatever. But Gen AI is novel and misunderstood and has nuance. It's commonly shortened to Gen AI. If anyone here is named Jennifer or Jenny, I'm sorry, they stole your name. In any case, there are problems with generative AI, and many of us have seen these across the web. What are they? Well, these are some of the most common problems with generative AI. Problem number 1, hallucinations. They are confidently wrong. Sometimes like me when I give talks, despite my best efforts. But they see things that are simply not there. Like Google recently rolled out a feature called AI overviews, where you search for something and they, instead of giving you just like result after a bunch of ads, they give you just an AI like generated output from Gemini, their large language model and assistant, and they use the name Gemini for everything. The problem with Gemini is it's so bad. It's so, like, there was, somebody posted a question to Google, how many cigarettes should a pregnant woman smoke per day? Just to test the AI, of course. And just for full clarity, 0 is the correct answer. Just in case there was doubt. But Google responded with an AI overview saying the typical pregnant woman should smoke 1 to 2 cigarettes per day. And like confidently, you know? And so the hallucinations are an absolute problem because there's an authority that comes with it, and there's a naivety with us, unfortunately. And so we need to think more critically about these things. Problem number 2 is there's a finite context length. Like if you have a long enough conversation with like ChatGPT, at some point it will just forget. And it will not know what it is. Like, by the way, nice weather. It's very strange. With Gemini, the largest context window around is 2 million tokens. A token is equivalent roughly to like one English word. I was going to say one human word, one English word. And so after 2 million-ish words, the top performing model just sort of forgets what you're talking about, which is kind of sad. And finally, there's a knowledge cutoff, meaning past a certain date, it just doesn't know stuff. So there's no basis for real-time data. Should I take an umbrella with me as I go to Pixel Pioneers? I don't know. As per my knowledge cutoff in September 2023, I can't help you. Right? That's kind of annoying. So these are the 3 huge problems with Gen AI. And these are the problems that AI engineers, can you please stop? These are the problems that AI engineers are solving across the world. So let's talk about them. The solution to all these 3 problems is not 3 solutions. The solution to, I feel like Steve Jobs doing the iPhone. These are not 3 devices. This is one. A solution to all these 3 problems is one thing, one technique that I think is very important in this space because it fixes all of them, an entire class of problems. It's called RAG. It's not a cloth that you abuse. It stands for Retrieval Augmented Generation. Retrieval augmented. If that sounds Familiar, it's because it is. Like, it's just a fancy way of saying you get a bunch of data from somewhere, some database, some source, some website, and then you use it to augment the generated output from a large language model, ChatGPT or Gemini, whatever it may be. So you get the context, you retrieve the context, you get today's exchange rate, and then you say, hey, ChatGPT, here's the exchange rate for today now, convert 50 euros to 50 pounds. Right? So you get the context and you give it. That's it. You can do this however you want. If you speak JavaScript, you could do a fetch request to some database, get the latest data, and then be like, ChatGPT, here's some context, now answer the question. RAG. This is the whole technique. I've really summarized it in a very basic sense, but that's all there is to it, for real. You just need to like get data and say, here's context, now answer. The problem is, of course, where do you get the data from? And how do you make sure it's like relevant to what the user has asked for? Because ultimately this is about user experience, right? There's no worse experience than a user going to do a task and getting back something that's useless, right? Like, help me convert, 5 pounds to 5 euros. I can't, sorry. Like, that's the worst user experience possible. So RAG can help make user experience better through that. There are some components of a RAG pipeline or RAG-based workflow. Fundamentally, you need data. Like, you can't augment any generation without data. So you need real-time data, preferably. You need today's exchange rate. You need the weather. You need whatever it may be that concerns the user. You need this from somewhere, and you need it from somewhere reliable. There's my company. We make a database. You can store your data there. You can store your data on device. So Apple does a lot of processing on device. You just need data, the latest data. And you need to leverage something called embeddings models. What are these? Machine learning models that are specifically trained to take natural language and transform each word into a number. Basically, that's what it is. However, these numbers exist in what are called high-dimensional vectors. And these vectors are embedded, literally, that's why they're called embedding models. They're embedded in high-dimensional space. Okay, what is high-dimensional space? And what is a vector? The vector is a list of numbers, fundamentally. And then again, you don't need a machine learning background for this. You just need to like speak English. A vector is a set of numbers. So a two-dimensional vector, the most popular two-dimensional vector in the whole world, what is it? What? Velocity? No. Maybe, could be. I was thinking about coordinates on a map. So like latitude, longitude, it's literally like a two list of numbers. That's a two-dimensional vector. If you add depth to it, you get 3 dimensions. So X, Y, Z, right? If you add some, say time is the 4th dimension, whatever. So we can reason in about 2 dimensions and 3 dimensions. These embeddings models map out space digitally in up to like 3,000 dimensions. Like, the human mind cannot comprehend this, right? But there's space, lots of space, and in the space you can embed numerical values that are inferred from natural language. So an embeddings model really just gives semantic meaning to words. And the reason I'm spending time telling you this is because when you run text, natural language, through an embeddings model, you get a big list of numbers, a list of about 1,000, 3,000 numbers. Each number represents a point in space. And the cool thing is, like words are associated close to each other in this high-dimensional space. So words like food, donut, crumpet, sausage, black pudding, they're all in the same space, so to speak. You can even picture this in your mind in 2-dimensional space. If it's like this, like food would be over here, and like vacation destinations would be over here, and airplanes would be, so they would all sort of be close to each other, the things that are related, right? That's what embeddings models do. They convert natural language to a list of numbers where there's semantic proximity to like words, okay? And finally, you get these vectors, these high-dimensional vectors, and you can store them in the third component of RAG, which is a vector store. And if that, again, sounds familiar, it's exactly what it sounds like. It's a database that's specialized for storing big lists of numbers. That's all. And since the database is created around vectors, it can perform vector search, which is, given an input, what should I have for dinner? An input, it looks at this, converts it into an embedding, okay, dinner, food, hot dog, food, whatever. And so, given an input, it can then convert the input to a list of numbers and check how close is this input list of numbers to all the lists of numbers in my database. Similarity search, okay? That's what vector stores do, and this is what makes a really great RAG workflow, because given a user input, you can search based on similarity, not just based on keywords. Is that clear? So you actually capture the idea of what the user wants as opposed to words that match what the user says. And I have a really great example of this I'd like to show you. But to further cement like RAG, I'd like to show you a demo of an actual RAG pipeline. Again, you can build a RAG pipeline however you want. If you speak JavaScript, fetch context, so you retrieve context, use it in a large language model, literally with text. You can do that. But let me show you a visual representation of a RAG pipeline to really cement this. So if we come over here to Langflow, this is an open source tool that we build internally. It's open source, and this is actually running like self-hosted. It's on localhost here, so it's not by some evil company that wants to steal my data. So what does a RAG pipeline look like? What we have here, it all starts with chat input, and it could be, should I take an umbrella, for example, right? Whatever, and this is just literally chat input. There's also an embeddings model. We just talked about that. So this thing is going to take my input and convert it into a list of numbers. Specifically, in this case, 1,536 numbers per list. And then we're going to feed this through a search engine. So again, we make this database, and we're going to give it an application token and an endpoint, and we're going to take its response from the search engine. So now it's compared the input list of numbers to the list of numbers contained in the database. And so we take its response, break it down into text chunks, because we don't want to overwhelm the large language model with a lot of text. And then we engineer a prompt. And by engineering a prompt, we take this so the context comes from the database after the similarity search. Using this context, answer this question. And this prompt really captures the essence of RAG. This is literally, you get context from somewhere and prompt it like this. And once you're done with the prompt, we then pass that prompt, we pass the prompt exactly to a large language model. So in this case, we're using GPT 3.5 Turbo. You can use whatever you want. And it will basically give you a response to that prompt. And what is the prompt again? Given this context, answer the question. And then we get the answer here. So if we played with this in the playground, I could do something like, how are you? And this is just really we're not doing any RAG. We're not getting any data. And so I could actually ask a question that's more time sensitive. For example, who won the Oscar for Best Picture in 2024, right? And there's knowledge cutoff here. It doesn't know. GPT 3.5's knowledge cutoff is like 2023. So let's see what the answer is. Hopefully today, there we go. Oh my gosh, that's not even what is happening. Gosh, that's awful, isn't it? And so I think that's maybe an error. Whoa, a lot of things went wrong. Let's start this again. Yeah. I love the demo effect. It's so brilliant. So let's try this one more time. And we'll actually build the flow. It's gonna just validate that everything's working. And so if we see a green, okay, perfect, chat output built successfully. Let's ask again. Who won the Oscar for Best Picture in 2024? Let's get rid of that output. Please don't say some weird machine stuff. If it does, I mean, that's probably, okay. Are you real? At this point, I love unpredictable behavior. It makes the case that AI engineering is young and you can fix it. Okay, well, this isn't working. No problem. I have a backup demo. So let's go here. Let's check out main. Ooh, git checkout main. And I'd love to walk you through the code of this. I don't think we'll have time, but npm run dev. I want to show you this demo because this is a very interesting one. Let's go to Netflix and watch some stuff because my demo didn't work. I'm just kidding. So Netflix, I'm literally going to Netflix and oh, there's a new season. Okay, so any Bridgerton fans here? No 14-year-old girls in the, anyway, so what I wanted to show you is RAG and the benefits of vector search. So how can we do that? Well, if I search here for movies with a strong female lead, right? Look at this. It's like, but this is how I think. This is how most of us think. Like it's Friday night. You're like, I want to watch a movie. I kind of want Scarlett Johansson and AI and you think like this. You don't go like, this is the name and search for it. Unfortunately, Netflix doesn't have vector search powered by Gen AI. So I built it. And I'd like to show you this demo to fully capture the nuance of RAG. So this is running here on my local machine. And I can type something to search for. So movies with a strong female lead. I'll just pick that one. And nothing will happen. Okay, there we go. So, and now it searches using RAG. And it may not, actually, this is definitely not gonna work. We'll just live program this together. So I have like 15 minutes. why not? So instead of all of this, what I'm going to do is make this font size a bit smaller. Yeah, instead of fetching from, actually, yeah, let's do it like this. So I have some RAG flows. Let me. Gosh, this is going well, isn't it? We're good. So I'll start this, and it should give me. I'm just going to remove one tool here. It's called find movies. This one. We don't need this. Get movies, go away, and that's just a RAG function. So we'll get rid of this. But I do have a tool called show trailer that does RAG. Okay, so let's say movies with a strong female lead. There we go. So here's some movies, and this is unfortunately just a chatbot. It doesn't give me like rich UI, but it's sort of in the same spirit, right? What we can do with RAG is get data from somewhere and show it to the user. So if I say, for example, Mulan, I think that's a really great movie. So show me the trailer for Mulan. And this is what I wanted to draw your attention to, is this is RAG. So it literally gets information from the internet about Mulan, and in real time will show me a blank screen. Just kidding, it's the internet. But it actually shows me the trailer here. And it is indeed like the old Mulan. So cool. And so what it's doing is it's retrieving data from the internet and showing me not just text, which is really a cheap modality nowadays. Everyone's building chatbots, but we can do better. We can do a lot more. And so it's generating UI based on what I asked for. And this is so cool. And we can do something like show me the trailer for Top Gun, right? Whatever you want. And it will recognize the meaning. Okay, you want a trailer, I'm going to do some RAG, I'm going to show it to you. Thank goodness it's the old one. So how does this work? This is how it works. So we have a tool called show trailer, and there's a description. When the user asks for a trailer, use this tool. And this description, unbelievably, is what the large language model will use at the right time. Like it has intuition based on the prompt that you write. It can literally infer, okay, you want a trailer, I don't have this capability in myself, it will use tools. And this is really modeled after the human brain. Because, for example, if you ask me to do a complex calculation, I'll recognize in myself, I can't do this, I need a tool, I need a calculator. This exact thing can be modeled with machines. And so, based on this description, we give the large language model a schema. This is just, we say you give the large language model would give this function a movie name that's a string. And then we write the function here ourselves. And what is this function doing? It's connecting to a database, in this case Astra, the one we make, and it's doing vector search, where it takes the movie name, converts it into vectors, as we talked about, high dimensional vectors, and does similarity search. And then it finds the closest movie that matches this and gives you, and then it gets the trailer. So this is RAG, it retrieves the trailer, and then returns you the actual UI that plays the trailer. And this UI can be literally anything. I could do a div and I could say h1, hello, pixel, and it's so cool because it's just UI. And again, I want you to think of really cool use cases for this. And we'll do like maybe a big class name like text 6XL, right? Okay, let's do one more thing. Instead of giving the movie name, we can say something like recommend movies about AI's future. There's Blade Runner, there's Ex Machina, there's Her, and there's a bunch of things. And finally, we'll say, show me the trailer for Her. And you can see that I just now changed the code a little bit. And so, good, thankfully we don't have this, but what I wanted to show you is just above the fold here, we have the thing that I wrote. It's generating UI based on its usage of tools when it needs it using RAG. Let's wrap up this demo by looking at the actual database that powers this. This is Astra, this is the thing we build. And we've got a database here, a collection called movies. And movies contains 1,083 movies. And all of the movies live here. There's content. And the content is sort of the name and the synopsis of it. And they're actually broken down into vectors, so I can search just here. I could be like sci-fi movies about robots, I don't know. And I search this, and what it's going to do is convert this text into a list of numbers, do a similarity search across the 1,000, and sort of sort this data set into that. And so as you can see, this Ex Machina, the Terminator, Creator, etc. So vectors allow you to do similarity search a lot better through RAG than keyword search. And that's just one use case. But I want to, and by the way, we're calling this generative UI. I want to draw your attention to the idea that chatbots are cheap. Okay, everybody is building a chatbot, but chatbots are so 2022 or earlier. I just showed you how you can generate UI components. And if this is a usability and UX and a design conference, that's why we're here. We want to create the best user experiences for our people. And if you give me like a text-based list of movies, I want something where I can like click on it and watch it immediately. And I showed you how you can do that. So I did use a chat interface to make a point, but I would love it if going forward we can see more than just text. If we can generate rich UI based on actual combinations of things that users care about, because ultimately that's why we do the things we do. We want to create, at least that's why I do the things I do. We want to create experiences that people enjoy using. So not ba.com. Like most travel websites, for example, it's like enter your departure, enter your arrival, and it's janky and laggy. What if we could do that better with Gen AI? Indeed, we can. And so maybe a simple example, you go to amazon.com or amazon.co.uk and you see a list of recommended products. That list of recommended products, instead of rule-based AI, which is programmers like reading your cookies from everywhere and coming up with things you may like, would be based in Gen AI. Meaning, what are some things that you've sought out? How can we benefit you? Like, okay, you just bought like a coffee grinder. Let's maybe show you things that your friends like. And again, you don't need to track people for this. That's the cool thing. You can just generate it based on the things that they themselves have searched for on the single website, instead of tracking them across the entire internet like they do with cookies. Okay, let's wrap up and talk about the future. Large language models have been a thing for a while. The problem is they're very, very large. They're super gate kept. You cannot train a large language model without hundreds of thousands, if not millions of dollars, and you need a cluster of GPUs. It's very expensive. And also, you can't run them yourself on your device. How cool would it be if you could? But you can't, because they require an enormous amount of compute. Also, because they're so large, they really don't know you. They're not like specialized. They're generalists. They're jacks of all trades and masters of none. So the future, as we actually see with Apple, who just announced Apple Intelligence, the future, or I guess the present at this point, is smaller, specialized language models that you can run on your device, and that because they run securely on your device, they don't have a connection to the internet, and you can share your data with yourself effectively. We're going to see more smaller, specialized language models as opposed to large language models. In fact, I'd like to show you, there's a great tool called Ollama that makes this really possible. So there's the team behind Docker. Anyone use Docker here? The team behind Docker, a lot of them quit and started Ollama, which is sort of like Docker, but for Gen AI. And so we could do something like Ollama run, but let's do Ollama list. So I've got all of these models running locally, and Mistral is an open source large language model. So I'll do Ollama, run Mistral. And this is going to spin up Mistral, which is a small language model that I can fine-tune for my specialized use cases. And it's going to run this completely without an internet connection. I can say, hello, tell me about UX. And all of this is happening locally on my device. I don't even have a big device. I just have like an M1, right? It's not an M4 or something. And I can run this locally. And I can do, remember we talked about RAG? I can feed in my data on my device and get secure, healthy recommendations. Finally, I'd like to wrap up this demo by showing you a tool called ACITOP, which is, again, it just runs on your machine. There's nothing sensitive here. And it shows you like metrics of how your device is doing. And I want you to pay attention to this specifically, my GPU usage. I'm not using a lot of GPU, but if I run an inference, so I can say, who created Apple, right? What you can see is, look at that. This will go, there you go. So inference is happening, you see? So all of this is indeed happening on device securely. That is one tenet of the future of Gen AI. And this is where, if you want to play, looking at tools like Ollama can really help you build things for you and your specific people. Another direction that Gen AI is going is what we're calling agentic or agent workflows. This term is conflated and used for many different things. I'm characterizing agents by their ability to perform actions on your behalf. Right now, large language models or Gen AI systems are really all talk, no action, right? They will draft an email for you, but they will not send the email on your behalf, even with your permission. There's no system that says, hey, I've drafted this email, now would you like to send it? There's also no system that says, hey, I noticed in your calendar, like you're meeting with your friend next week, but you don't have a venue, you don't have a place chosen. I know you like Indian food, like, shall I make a reservation. Like it can't do stuff on your behalf. This is starting to change, especially with things like Olama that allow on-device processing in concert with some cloud processing. This is the whole basis behind Apple Intelligence and the future of Gen AI as well. By the way, all of this uses RAG. This is why I spent a lot of time showing you RAG, because if you have a small specialized model on the device, it needs to get context about you from somewhere, right? Ideally, it's not trained on your data. And so you retrieve that data, and in case of Apple Intelligence, they're retrieving it from all of the data that's on your device and feeding it to the LLM as context. Given this context, now answer this question. Okay, let's summarize. We covered a lot. I really hope I've avoided the hype. Listen, I'm not here to tell you like, this is great, go use it. That doesn't really work very well with people who have a prefrontal cortex. Sorry, was that harsh? If I violate the code of conduct, I apologize. But I think it's important to capture the nuance around these topics. I think it's important to make it accessible to you. And I hope, indeed, that you feel like it's more accessible. So in summary, we covered a ton of things. We started by just talking about what is AI engineering? Is it different than machine learning engineering? We looked at that graphic, right? That has this strong line, the API. You have machine learning, you have AI. Andre Karpathy himself is like, listen, like you don't need to train anything. You just solve problems with AI. And then we looked at the problems: hallucination, limited context, and knowledge cutoff. And we solved all of them categorically with RAG, a system that can go retrieve like a movie trailer that it doesn't know about and then embed it in the screen with you. And finally, we had some ideations about the future. I hope this has been helpful to you. I hope that you find these concepts more accessible. And indeed, I hope if I ask you now, do you think you could be an AI engineer? Your answer would be somewhat different. Thank you so much for having me. Took your time.